Okay, so we've learned about ratios, rates, and proportions, and now we're going to put them to use because, yes, this is actually math that you could use in real life. So let's look at a first example. So let's say you have something where you're mixing cement, right? And you need 15 cubic feet, that's what that little 3 means, of cement to make 80 cubic feet of concrete. Okay, so they're giving us basically the information that we need. They're telling us the rate. Like, you may think it's a ratio because of they both have feet cubed, but the units that we're actually working with here are cement and concrete. They're two different things, right? It's like two different ingredients, if you will, for a recipe. All right. So whenever you're given a ratio and proportion problem, like in a word problem, what you want to do is set up your word problem like this, okay? You want to have 2 lines, and you put your first unit up here, and you put your second unit down here, put an equal sign, put a line, put an equal sign, and put another line, okay? Now, the reason you do this is because you need to, where you put the units matters, right? So if you have unit A here and unit B here, then what you've got to do is actually, anytime you put a number that represents the first unit, it goes where you put unit A. So you put unit A on top, so all the unit A numbers will go on top. All the unit B numbers will go on the bottom, okay? And if we look at this question, so we need cement and concrete. Those are the things. Now what goes over here is you put in the rate over here. And that's the one that they give you. So that's given. Okay? Okay? And then what you're going to put over here in this last line, or this last section, I guess you could call it, is you're going to put your unknown. So you're going to put your x in there. And then you're also going to, on the appropriate side. So if you don't know unit A, your x would go up there. If they're asking you to find unit B, you would put your x down there. But they're going to give you one unknown, and they're going to give you one known as well. Okay? So that's like known. Okay? So that probably doesn't make a whole lot of sense, but let's try it. So we're going to go line here, line here, line here. Okay? So our first unit, okay, was cement. So we're going to put cement up top. Okay? Then we're going to put our second unit, which was concrete, on the bottom. Okay? Now we look. Now we've got cement to concrete. Now the rate that we were given, it tells us 15 cubic feet of cement. So we're going to put 15 up top because cement is up top. And 80 feet of concrete goes on the bottom because concrete's on the bottom. So we have, and this is where the rate comes in, okay? So this is 15 cubic feet of cement to 80 cubic feet of concrete, okay? Now we have to put our unknown and our known. Now it's saying in problem A, if you have 55 cubic feet of cement, okay, so that's telling us we have 55 cubic feet of cement. Cement goes on top, so we put 55 on there. And then it's asking us how much concrete can you potentially make. We don't know the concrete, so that's where our x goes, okay? Okay, now that we've got it here, what we do is we do our cross multiplying and solving the proportion just like what we did before, okay? So we're going to go 80 times 55, okay? And then we're also going to go x times 15, and then x attaches to 15, okay? And then our last step is we divide by whatever's attached to x, so we're going to divide, well, actually we should multiply this out first, sorry. So 80 times 55 is 4,400. You can use your calculator for this. Okay? And then we have 15x over here. And then we know our last step, we got to divide by whatever is attached to x, so we got to divide both sides by 15. And when we do that, divide by 15, divide by 15. So we know that the 15s will disappear now, and we're just left with x over here. And then 4,400 divided by 15 gives us 293.3 repeating. So if it repeats, you can just put a line over top. So what this is basically saying, and if you think back to what x was how much concrete we need, or how much concrete will be created if we have 55 cubic feet of cement. So you would say, the question asked us, if you have 55 cubic feet of cement, how much concrete can you potentially make? So you could write, you can make 293.3 cubic feet of concrete with 55 cubic feet of cement. Oops. Okay. So let's try question B. So now it's saying if you wish to make 200 cubic feet of concrete, so it's giving us the concrete and it's asking us how much cement. So if we go back down here, okay, again, we're going to set up our thing. Line equals, boom. And we said cement is here and concrete was here. And our rate doesn't change from the question. If you look up here, the rate that they give us was 15 to 80. So that's going to stay the same, okay? So 15 cubic feet of cement will make 80 cubic feet of concrete. And then when we put, it said if you want to make 200, if you wish to make 200 feet of concrete, so concrete goes on the bottom, so, and it's 200 cubic feet of concrete, so concrete's on the bottom, so we put our 200 there, and the question was asking how much cement do you need? Well, cement's on top, and that's what we don't know, so that becomes our x. Okay, now that we've got it to that point, we're just doing our cross multiplying. So we go 80 times x gives us 80x, and then 200 times 15, so 200 times 15, okay? 200 times 15 gives us 3,000, and then we have 80x, and now we know we have to divide by what's attached to x, so we divide both sides by 80. And when we do that, the 80 disappears over here, and 3,000 divided by 80 gives us 37.5. So if you remember, x was cement, so that 37.5 is 37.5 cubic feet of cement. So you need 37.5 cubic feet of cement. Oops, can't seem to spell cement. To make 200 cubic feet of concrete. Okay, and again, that 200 came from here because they said how much cement do you need to make 200 cubic feet. So just keep in mind where your x is depends. You could have flipped this around. It wouldn't matter as long as you made sure that the 80, like if you put concrete on top, you could have done it this way. You could have had concrete here, and sorry, I'll just equals, and then cement on the bottom. And what you would have done is just put your 15 on the bottom because cement is on the bottom, and you would have put your X on the bottom because we were trying to find the amount of cement, and then you would have put your 80 on top because concrete is on top, so you would have put your 80 and your 200 on the top. And the math still would have worked out. Either way would work, okay? So the key is just make sure you have unit A, unit B, and then wherever you place them, just make sure you're consistent and you put the numbers for that unit on the same line as where you put your words. Okay, if we look at the next example, it says label on fertilizer tells the farmer that 70 kilograms of fertilizer will cover a 20-acre field. So the units that we're going to be setting up, so we're going to have, again, we do our lines. The units that we're going to have to look at are the fertilizer to acres, or kilograms to acres. So I would just use kilograms up here, and then I would put acres on the bottom, okay? And now, so now we have to get our rate, okay? And that's, they tell us up here, 70 kilograms to cover 20 acres, so our rate will be 70 kilograms to 20 acres, and we know that kilograms goes on top, so we have 70 kilograms to 20 acres, okay? Now we look at our questions. Now our questions will tell us what goes where. So the question here is saying how many kilograms. So we don't know the kilograms, so that's going to be our X, okay? And it goes on top because kilograms are on top. Will the farmer need to cover a 95-acre field? So it gives us the acres, 95, and acres go on the bottom because that's where we place them, okay? Now that we've done that, now we do our cross multiplying. So 20 times X, 20X, and then 95 times 70. 95 times 70, okay? And then 95 times 70 gives us 6,650, and then we have 20X here, and now we divide by whatever is attached to X, so that just leaves us with X, and then we divide by whatever is attached to X, and so we divide it by 20, and that gives us 332.5. And it's 332.5 what? Well, X was up here, which is kilograms. So how many kilograms of the same fertilizer will the farmer need to cover a 95-acre field? So he needs 332.5 kilograms to cover 95 acres. Okay. Next question, B. If the farmer has 120, so we're just going to rewrite this again. We're going to rewrite, so we've got our lines. Okay, so we've got our lines. And then I'm going to switch it up. I'm going to actually put the units in the different places here just to show you that it still works, okay? So we've got kilograms on the bottom. We've got acres on the top. And the rate won't change because it's the same rate that they gave us in the question. So that's 70, you need 70 kilograms of fertilizer to cover 20 acres. But now kilograms are on the bottom, so I just put my 70 down there, and I put my 20 acres up here. And now the question was asking us if the farmer has 120 kilograms of fertilizer. So wherever the kilograms are, that's where we're going to put our 120. So if we go back down here, so kilograms were on the bottom, so we put 120, and we don't know, it's asking how many acres can that cover. So we put our X on top. Now we go, once we've got that set up, cross multiply, okay, and then we have 70X, and then 120 times 20, and that gives us 2,400, and we still have 70X over here. And now, to get our final answer, we divide by whatever is attached to X on both sides. And then 2,400 divided by 70, again, you can use your calculator, is 34.29, roughly. So if you round off, you just put a little dot to indicate that you're rounding off. So basically, it's if you want to make, if you have 120 kilograms of fertilizer, that means you can make, X was how many acres, so that means that we could cover 34.29. So you can cover 34.29 acres with 120 kilograms of fertilizer. Yep. So this example looks at a scale plan, and you see this on maps, like they talk about scale, 1 to 30. So whenever they do a scale, you see this 1 to 30 ratio here. What that represents is like 1 usually centimeter on the plan on the map or on the plan represents 30 centimeters in real life. So usually so the 1 to 30 is like saying the plan, the measurement on the plan to the actual like real life measurement, okay? So that helps us in setting up our proportion, okay? So we've got our lines here, we do our lines, okay? And we know that because we're dealing with a scale, we're talking about the plan to the actual, 1 to 30. So we can go plan on top, and then the actual or real on the bottom. And we know our rate, we know it's 1 centimeter on the plan represents 30 centimeters in the actual house, okay? Now, if the dimension on the house plan measures 13 centimeters, so that's the house plan, so that 13 centimeters is a plan, so that goes up top. And then it's saying, what is the actual dimension? So we don't know the actual dimension, so that becomes our X, okay? And then we're just, once we've got it set up, then we're just into our cross multiplying, okay? So 1 times X, that's just going to be X, because 1 times 3 is 3, 1 times 2 is 2, so that's just going to be X. And then 30 times 13, and then again, if you need to use your calculator, you can, and that gives us 390, okay? So if the dimension on the house plan measures 13 centimeters, the actual dimension on the house would be 390 centimeters, okay? B, so we'll set this up again, plan, actual, and then okay, so we've got 1 centimeter again on the plan represents 30 actual centimeters. Now this question is asking if the length of a completed room in the house is 450 centimeters. So that's a completed room in the house, that's our actual, and it's 450 centimeters. Just draw a line there. Okay, so that becomes our X, because the question is saying what would be the corresponding measurement on the house plans. So we want to know the house plan, we don't know it, so we put our X there. Okay, and now we're just into our cross multiplying. So 30 times X gives us 30X, and 450 times 1. So 450 times 1 is 450, and then 30x, and then we divide by whatever is attached to x, and then that leaves us with x on this side, and 450 divided by 30 is 15. So if we had a room that was actually 450 centimeters long, then that means that on the plan the room would be 15 centimeters long. Okay, so we've got another ratio and proportion question here, so we might as well just start setting things up. our lines, our equal signs, and our lines. Okay, now we just need to figure out what our units are. So let's read the question. To estimate the number of fish in a lake, a fisheries officer catches 150 fish from the lake, tags them, and throws them back. He returns the next day and catches 70 fish. Okay, he notes that of these 70 fish, 28 have the tags that he attached on the previous day. Estimate how many fish are in the lake. So this is where people might get confused because you got three different numbers. But if you think about, we're talking about like what we want to know is we've got tagged fish. Okay, so he knows that of these 70 fish, 28 have the tags. So we have tagged fish is going to be 1. And then what we're trying to figure out is total fish, okay? Okay, so now we have to figure out what's the rate, okay? So he returns the next day and catches 70 fish. He notes that of these 70 fish, 28 have tags. So tags, we have 28 tags, and tagged fish goes on top in blue there. So we have 28. And out of the total fish, now this isn't total fish in the lake because we don't know how many there are. So, because how do you know how many fish are in a lake, right? But the total fish that he caught 70 of those. So that's where that 70 will go, is under the total fish, because that's how much he caught. Okay, now going over to our last section over here, we have to go back to the beginning and saying, to estimate the number of fish in a lake, a fisheries officer catches 160 fish from the lake and then tags them. So those, every single one of those fish that he caught, he tagged. So those are tagged fish. So tagged goes on top. So 160 fish up top. And then it's saying, the question is asking how many fish are in the lake, because it's impossible to know just by looking at a lake, but we can estimate it based on his tags. So total fish is on the bottom, and now we're into our cross multiplying. So 28 times x is 28x, and then 70 times 160, okay? And then 70 times 160 is 11,200, and we have 28x over here. Then we divide by whatever's attached to x, 28, 28, and then that leaves us with x, and 11,200 divided by 28 gives us 400. So again, what does this 400 represent? It represents the total fish. So this rate here was the rate for that next day, when he came back the next day. Okay? This is for the total, for the entire lake. So how many fish are in the lake? You could say there, you could estimate that there are 400 fish in the lake. Okay. So again, the key with these word problems is get unit A, unit B, and make sure all the numbers that apply to each unit stay on top. So if you put tagged fish up top, every time you have a number for tagged fish, put it up top. If you have total fish on the bottom, every time you have a number for total fish, put them on the bottom, and then you're just doing your cross multiplying and then dividing by whatever's attached to x. If you have any questions, see your instructor.